Hello students, welcome back to OrganiChemVerse. In this video, I am going to solve a JEE Advanced level question which involves Diels Alder reaction, ozonolysis and reaction of carbonyl compounds. So let's get started. So we have a diene molecule. Diene refers to there are two double bonds, right? And then there is a dienophile, that is ethyne molecule. So it undergoes Diels Alder reaction. In Diels Alder reaction, there is a cyclization process and we are going to get a cyclic product like this. The triple bond will become double bond, right? There is a pi bond formation over here. What about the methyl groups? They are as it is, like this. So this is product P, right? This upon ozonolysis, it's a reductive ozonolysis. In ozonolysis, the double bonds are going to get cleaved and we are going to get carbonyl compound like this. Okay, since this molecule is symmetrical, right? So the same molecule is going to form twice, right? It's a aldehyde and ketone containing compound, right? So now this is what? This is product Q. This is treated with hydroxylamine, NH2OH, also known as hydroxylamine. We know that both aldehydes and ketones do react with hydroxylamine, but since it's given only 1 mole, right? Aldehydes are more reactive than ketones, therefore it's going to react with the aldehyde. It's undergoing condensation, that means removal of water. How the water will be removed? H2 from here, oxygen from here will be removed and we are going to get a product like this. There is NOH and H. So whenever aldehydes react with the hydroxylamine, we are going to get aldoximes. Okay. Now these aldoximes are quite reactive, right? And we have carbonyl, that's the reason. And this oxygen acts as a nucleophile and it is going to react with the ketone. So how to write the product? Look at this. This is a cyclization. So how many atoms are involved in forming a cycle? 1, 2, 3, 4, 5. So the product will be not definitely D. You can eliminate that, right? So there are 5 atoms, not just carbons, because we have nitrogen and oxygen. So it's a heterocyclic basically. So we'll write 5-membered first, right? And look at this. I'll write the nitrogen over here, right? The nitrogen is attached to oxygen here. The oxygen is attacking this carbon, right? The oxygen is attacking here. That means there will be OH and methyl. It will be O minus obviously, but that will become OH, right? And we have written so far here. And then there is a methyl here. This is the carbon I am talking about. The adjacent will be having a double bond with the nitrogen, right? The adjacent, whatever atom is there, it will have a double bond with the nitrogen. Now, on adjacent carbon, you see there is H and OH, right? So what happens here? Again, it will undergo dehydration. What is the driving force now? The driving force is that it is going to form an aromatic molecule. You can see here the aromatic molecule is a major. That's the reason we are doing a cyclization here also, right? So now look at this. Oxygen is here, nitrogen is here, the double bond is here, and a new double bond is going to be formed here. And where are the methyl? The oxygen adjacent carbon will have 1 methyl. Next to that, we will have 1 more methyl group like this. Okay, so this is the product form, the final product, that is R. So it says it's going to be aromatic in nature, right? So and there are 5 carbons. So look at this, 1, 2, 3, 4, 5 carbons, and there is a nitrogen and there is a oxygen. And let's count for the hydrogen. 3 plus 3 6, and here we have 1 more, 7. So it is matching with the formula whatever is given here. But let's see which is the product here among A, B and C. The methyl should be adjacent and it should be adjacent to the oxygen, right? Therefore, the right option is option C. So students, what all we have learned here? Diels Alder reaction, ozonolysis, and selective reaction with hydroxylamine, because we have both aldehyde and ketone. Remember, aldehydes are more reactive than ketones, hence it's forming aldoxime, not ketoxime. The aldoxime is forming cyclized product. How do you know? Look at the options. It says it's going to be aromatic. So based on that, you form an aromatic compound and compare with the formula given over here, and it is correct. Then verify where the methyl groups are and choose the right answer. Thank you for watching this video.